Yeah, welcome back to the Frankfurt Customer Briefing Center, and thank you for your interest in our discussion panel, Independent View on Short Circuit Protection in Industrial and Data Center Environments. I'm Martin Canziora, and I'll be leading you through what is sure to be an exciting half hour. We will gain from 3 different perspectives on a topic which is essential in data center, smart building, and industrial market sectors. I'm joined today by Güven Narin. Güven is an independent electrical engineer and expert. He advises engineers and approves electrical installations. Uberto Vercellotti is in market and product development at the test institute KEMA Labs. And KEMA Labs is well known. KEMA Labs is well known for testing. We will talk about this later. And Henk Noon is Senior Business Development Manager at Panduit and an expert on short circuit protection solutions in these key application areas.
Good afternoon.
Güven, my electrical engineering studies ended quite a while ago. However, Güven, you may have alarming experiences from your business life, especially with regard to professional wiring and cabling. Can you briefly explain your thoughts on the difference between short circuit currents on medium voltage and low voltage, and how important is short circuit protection in this context of wiring and installation of cabling systems?
Thank you, Martin, for your introduction. So since our discussion today is about industrial sites and also data center environments, let me just give a brief overview about network and network planning, because these are the key elements regarding the requirements and analysis inside of those sites. So basically, when we talk about industrial sites, you see some examples picture in the background, I guess, also the audience. So basically, when we talk about industrial sites, to come to your first question in medium voltage environments, basically, we have in Germany, since we are sitting today here in Germany, in Frankfurt, 10, 20, 30 kV as a medium voltage. This is a typical voltage level, what we have there. And then we are transforming it with a transformer, which is also a key element inside of electrical network planning, into low voltage, right? So, and the low voltage voltages are, let's say, 400 volts. This is the standard requirement what we have there. And then, of course, it depends where your industrial site is connected and to which transformer it is connected to calculate also the short circuit currents. So that means typical industrial sites, they are connected to the network operator, and the network operator is giving you the short circuit current, which could be there at this point at a maximum level. And typically what we have there is 16 kA, 20 kA, 25 kA on the medium voltage side. So this is really depending on the transformer which is at the network operator. And this transformer is, let's say, transforming from 110 kV, which is high voltage, to medium voltage 20 kV. So typically this transformer is giving us a short circuit current for the medium voltage side. So then now coming to the low voltage side, and low voltage, as said, are 400 volts. This is then depending on your transformer. Yeah, the typical transformer inside of an industrial site has 1 MVA. This is a typical one, 1 MVA, 1.6 MVA. This is a typical transformer inside of an industrial site. And then when calculating it, you will see that the short circuit current on the low voltage side is much more higher. So typically we have 50 kA as a short circuit current. And then at the end, when it comes to the cable cleats, of course, on the mechanical stress, we need to think about the peak of the short circuit, which is at the very first moment of a short circuit, within, let's say, milliseconds. It's the very first peak. I think we will see later on a video showing that. What happens when there is a short circuit. So we are multiplying this 50 kA, which is on the low voltage side, by 2.5. So, and this is the peak. This is the peak short circuit current. 125, 150 goes up to 150, whatever. What kind of transformer you have in your system. So this is the, let's say, the view on the industrial sides, and let's now come to data centers. Since we were talking about a little bit earlier about it, in Frankfurt, which we have one of the biggest internet access points globally speaking in Frankfurt in terms of data centers. So the traffic in Frankfurt is the biggest one globally speaking. And we have a lot of companies here, and they do have their own high voltage transformer.
Okay.
So they have their a big transformer, 110 to 20 kV, with a 50 MVA. So this is only one data center, 50 MVA, which comes to a 50 kA short circuit current.
That's a very good point here, and we will come back to the differences between this later in our discussion. But that brings me to the next point, the CHEMA laboratories, and we have Uberto Vercellotti here. And I know CHEMA labs, they have several sites across the globe, and they have an expertise combines traditional techniques with state-of-the-art equipment to facilitate every kind of grid installation and layout from medium to high voltage, correct? My question is, which industries are demonstrating an increased demand for performance and safety in this area? And is there a change for a fast data scale-up, what you mentioned as data center or artificial intelligence applications, for example, is used in data centers, change the short circuit protection requirement in these kind of facilities? Uberto.
Thank you very much, Martin. Thanks a lot for this question. But first of all, let me say that nowadays the fuel for social and economic development in the transition are digitalization and decentralization. That means much more information to be delivered, and as soon as you want to deliver information and power, a cable network is mandatory. So in the near future, we will see an increasing amount of kilometers of installed low voltage, medium voltage, and even high voltage cable. You know in Germany what's going on with the corridors from the Baltic Sea towards Munich and so on. So this is the first point. Second point is that cable are good things, good product, but in case of high current circulating for whatever the reason, a failure, a short circuit, you may have two very strong, harsh effects. One is a thermal effect, and the other one is a dynamic that Guven already introduced. Thermal effects means that you can have a very strong and localized increase of temperature, and this can lead to fire. And this can create big problems, especially medium voltage tunnels and network. Talking about dynamic effect, the mechanical stresses that has already been introduced, here is the place where strong cleats and strong products are needed by the transmission and system operators, because to cover your second question, Martin, I think that nowadays transmission and distribution system operators are presenting more and more increasing requirements in order to fulfill the safety point of view for their network, because safety it's a duty, it's not a possibility. Especially in Europe and in the USA, whenever system operators pay penalties if you don't have the availability of the electricity along 24 hours per day, it's very important to have a reliable connection.
Thank you, Roberto. And that's a good handover. So the question is, how can we protect and what is the best way to protect against short circuits in cabling from the perspective of both industrial equipment facilities and data centers? As we have heard, data centers is crucial and the traffic is increasing. Henk.
Thank you for that question, Martin. When we speak about short circuit, what actually happens in case of a short circuit event? Now, there's a lot of things that you can say, but it's easier to show what actually happens. So what you see here on this video is a short circuit event that only happens on a cable over the length of 4 meters. Now you have to imagine that this happens in an environment where people work, and you actually work in that area, you walk around that area, and this cable starts flying out. So what you have to do is first of all make sure that the people are safe in case of a short circuit event, but also that your equipment and your manufacturing floor is secured, whether it is a manufacturing floor, a facility, a data center. Make sure that your cables are secured in case of a short circuit event. Now, as said, as you see on this video, these cables really fly out. So there is a certain international standard. It's the IEC 61914-2015 regulation, or standard actually, that tells you how to install a cable in a correct way. Use a cable cleat. Now, a cable cleat, what is a cable cleat? It is, according to this IEC regulation, it is a device that is being used to install and secure a cable at certain intervals on your infrastructure. So 2 very important things here. First of all, secure the cable in case of a short circuit event, but also the interval is very important when you want to secure a cable, whether it is in your infrastructure or your data center. Is this correct, Kuven?
Yes, thank you, Henk. Especially when I come to the design and construction of the switchgear and the whole network, this has evolved the last years. So basically, when I was starting, this standard, what you are mentioning, was not available, was not there. Okay,
right.
so we were designing and engineering switch gears and cablings without that standard.
Are we talking about this IEC 61914 from the different years? 2015 is your topic, right? Hank, are we talking about this standard?
Yes, it's all about this standard because 20 years back, please correct me if I'm wrong, I'm not aware about this standard 20 years back. So we were using a different kind of standard, and which is available, let's say, early in the 70s already in Germany. And then it came up the IEC and the European standards, which is the 16909, which is about calculating short circuit currents. So this is, let's say, the fundamentals of calculating what is then written in the new standard, right? So in the new standard, lots of calculations are coming from these, let's say, fundamental standard.
Uberto, do you have also same experiences with your customers or your companies which are going to test this in your laboratories?
Yes, I have to say that in the near past, that means in the last couple of years, we received an increased amount of requests to deal with such a situation. Also, to simulate, for example, we simulate a real accident happened in a substation in Paris because this was asked by some French customer, because there is a need to have a real understanding what can happen in case of very high current circulating in a medium voltage network. And the video that, as far as I remember, this video is taken by a test performed in Kima Labs laboratory.
Yes, correct.
Yeah. So the cable accessories, for example, and the fixing the weak point of this cable installation, correct? So the question is, what can you do to avoid this in your environment?
Well, there are different ways to look at it. First of all, you have to think about, as mentioned before, what is the maximum peak current? What actually happens in case of a short circuit event? Do you go for a calculated solution? Then you really have to think about what are the different options that you can install to secure these cables. Also, a lot of things that you have to keep in mind, apart from the maximum peak current. What is the weight that is accepted, for example, if you work with ladder racks? The total cost of ownership, something that is very important to Penduit. If we advise a solution on how to install your cable cleats, make sure that you do not just follow the standard based on the fact that says you need to use a traditional stainless steel cable cleat every 600 millimeters, because there may be an option, if you look at the total cost of ownership, to maybe at every interval install a double loop stainless steel solution, which we'll come to next.
Okay, so Penduit offers, this is what you are having on your mind, a huge variety of solutions for short circuit protection. And one of them being the double loop stainless steel. And I think something of this is here on this table. Are they a good alternative for the traditional stainless steel Cleats?
It's a very good question, Martin, because we often get that from our customers. If you look at a traditional environment, if you look at the specifications, we often see that a stainless steel cable cleat is already in the specs, whether it is a stainless steel cable cleat, sometimes it's advised to use an aluminum one or even a polymer one. But what we also advise is look at the alternatives. We have here two examples of a double loop stainless steel cable cleat. The first one here is what we call a strapping solution. The second one is a ball locking solution, the one right there, thank you. So these are very good alternatives, but have a very big impact on the total cost when you look at how many cleats you have to install. If you look at an average, for example, a data center where you have to install 10, 20, 50,000 cable cleats, it will have a very big impact. So that's why we always say, let's look at every project together and see what the best advice is for your problem that you have.
So when I think about the key areas and the most faults, and you have shown some nice pictures, which are originally not nice because it's a kind of a fault and you should not install this in this kind of way. But what are your key areas in this topic, in this field?
Yeah, I mean, do you mean
from the short circuit risk here?
Yeah, of course. When we look into data centers, into industrial sites, it starts with a switch gear. Then from the switch gear, as I mentioned before, we have the transformer, and in between we have the cable. And let's give an example from a last site, what we had here, a high-rise building here in Frankfurt, which was built up, I think, around about 150 billions. And then we are discussing about cable cleats, right? So they were missing. And because of the costs. That's typically what I would like to say to Henk. Typically of the costs, they are just not inside of a calculation, inside any kind of technical advice. So they are at the end missing at the place. So, and typically this is the weakest point, the connection from the cable to the switch gear. This is the interconnection point where you bolt the cable to the switch gear, either on the medium voltage or on the low voltage side. This is the critical point where you need to secure the cable to make a safe switching possibility, right?
Correct.
But nevertheless, when you switch a switch gear, you will not be able to switch before the first peak.
But
so this is when it comes to the cable cleats.
Yeah, and that's something, you know, when I see this cable cleat, for me it seems like, okay, it's a cleat, you just fix the cable, that's it. But there is some differences between the different IEC 61914 from 2015 or from 2009. What is the difference here?
Well, correct. One of the, Umberto, would you like to answer that question?
Yes, maybe Umberto. Sorry.
I think it's very important, the advice that are included in the 2015 edition, because this changed dramatically the situation compared to the old standard. I think that now, according to what Guven was saying, we can have a better future looking at this new standard, because it give us better ideas on how to install every 600 millimeter and how strong should be the cleats.
Okay. Henk, do you want to add something here?
Yes, what I would like to add is that if in a lot of cases, and especially for new installations, correct me if I'm wrong, but new data centers, new facilities, the IEC standard is often already in the specification.
Okay.
That makes it easier for the customer to go and look for a correct solution. What a customer often forgets is existing installation. So what we also offer as a service is basically a data center facility check, for example, or a facility check just to see if your production environment where your cables are installed, is it secured in case of a short circuit event? Because we have a lot of solutions that can be installed after the cables are already there. So please keep in mind that with this IEC standard, there is a standard, but on the other hand, also look at your existing situations, your existing facilities, existing data centers, to do that data center sanity check or that facility sanity check.
And it is possible to install this also if the installation is already there?
Absolutely. We have different types of solutions that you can either install before that the cables are being drawn into a data center, but also afterwards. So yes, for both we have a solution.
So meanwhile, we have received a question from the audience. Oh, sorry, Uberto, you wanted to say
No,
something.
sorry, but just to add one thing to what Henke already said. Safety is a duty. So duty is for every day of the year. No, that means not only for new installation, but as Henk said, also for old installation. And here is the situation where you may have a high failure rate because, of course, with the aging of the cable, of the accessories, unfortunately, joint and termination are very weak point along the network. So it's very important that you check also for the already existing installation, not only for the new ones.
Okay,
Yes.
good. Thank
Thank you,
you.
Bert.
Thank you. So I'd like to go and grab the question from the audience. Thank you for the question. If there are some additional questions, I invite everybody who is following this discussion to just shed in your questions. Jenny, can you provide this question, please?
Yeah. So what's the ideal spacing of UTP Cat6 cable to high voltages lines?
Maybe
Say
that's
it again, sorry.
yeah. I think that's more a question regarding network cable installations, not power cable installations. UTP unshielded pair, or do you want?
Yes, I understand the question, but in a lot of cases you can install these cables without using a cable cleat solution, because here we speak about a very low peak current. I mean, if there even is a peak current at this situation, because the voltage is so low, the amperage, of course, is so low that it doesn't really, I'm going to say it doesn't really matter. You have to secure your cables in any way. But these specific solutions are really for short circuit protection when it comes to, well, a very high amperage, for example.
Yes. So, but
Yes, absolutely correct, Hank. We are talking about real current flowing, let's say, inside of the cable. So it's a power cable, and we need several amperes and several short circuit kiloamps to provide these cable clamps to secure the cable. Because when we talk about overcurrent, we talk about overload. This is what Uberto was saying before, and short circuit. We talk about both. Overcurrent is overload and short circuit.
Is there any other question? Not yet. So I have one question regarding the cable cleats and this norm, the IEC 61914, and the changes over the time. It seems like that there is still some kind of missioning to the market. So not everybody is aware of this. So there is a need of this knowledge. We can provide this. We can provide this with the test or the checkup, what we provide, or what you probably also provide to your customers at the KEMA labs as well. So, but it's still kind of missioning to the market.
Correct.
What is the perception when you talk to the people? Are they open for this? Is this something, oh, I've not been aware to this?
Please.
It's not only about being aware, it's also about the change that sometimes that people have to go through in their minds, because in a lot of cases they think about cable has to be secured. It has to be an aluminum solution, a stainless steel solution, or a polymer solution. But there is a huge variety of double loop stainless steel solutions that we also provide into the market. And the great thing is, and especially if we get these questions from the customers, is that they were all tested at your facilities, Umberto. So that we have, for each and every solution, we have tested them. We also, before we actually tested them, used our own software that Penju had actually created.
According to this 2015.
According to the 2015 regulation. And that's why for each and every solution, we can provide this KEMA test report to show that all of these are, according up to a certain maximum peak current, of course, the correct solutions for this.
All right, maybe a question in between. What is the maximum short circuit current, the peak, what you can provide with the different solutions?
Well, we haven't tested the maximum. Being a US company, we tested up to a certain limit. But for example, if you go to the double loop stainless steel with the bolt locking system, you can go up to a maximum PK of 77 Ka. If you go to the what we call the buckle strap here, it goes up to 192 Ka, which is already extremely high, I would say. Even up to 200, 220, we go through the stainless steel. So it all comes down to, we haven't tested it to the maximum, but It all depends on what is the situation, of course, but up to 220, I would say, we cover a huge part of the industry so far, right?
Yes, correct.
Okay. What is about this plastic cable cleat here?
The polymer one. Or the
Polymer
plastic
one. Sorry, polymer
Again,
one.
here it all comes down to, so you see a lot of them are what we call a trefoil layout. The stainless steel cable cleat you see on that side and the aluminum on this side, they're limited, of course. They're limited not only in the diameter of cables that you can install with it. One of the benefits, of course, is that if you look at the stainless steel one, it has a spacer in it. So with one stainless steel cable cleat, you can use a huge variety of different kind of cables. For example, if you look at the CCSSTR, the 3036, it means that you can use the cables with an outside diameter from 30 millimeters up to 36 millimeters, for example. Okay. But if you look here at the double loop stainless steel solutions, then you're not only limited to the trefoil, you can install a single cable, a trefoil, but even a quad layout. When we go to a single cable that we want to secure, we usually go to what we call here, this is a two-hole polymer or two-hole aluminum that you see here. We also have a one-hole aluminum and a one-hole polymer. So it all comes down to what is the type of installation that you want to do, what is the cable you want to secure, and then depending, of course, on what our software says or what the calculations say, what is the distance between two installations that you have to do.
So it seems that there is a strong need to have broad experience and competence in this field. I have figured out that you have this competence, and Uberto, you as well. I know, and I just want to invite you, the audience, to visit the website panduit.com. We have also a German website, panduit.de. The other websites in the languages are following in the future. There you can also see calculation tools. We have an app available also for the cable cleats calculation, so you can edit your current in your environment, and then it's much more easier to figure out which of these different types. For me, it sounds like even when I'm an electrical engineer, I'm not the expert like you. It sounds a little bit, okay, I'd like to get a knowledge about this. Would you like to give just a brief explanation about how this works with this calculation tool?
Well, the great thing about this app is, and I'm grateful that you actually mentioned it, because it's a great tool. So you have the app on your phone that you can use whenever you are in a data center or a facility, and you want to know immediately what type of solution you have to select for this installation. On the other hand, there's also the web application. And the great thing is that you fill out the outside diameter of the cable. If you know, you fill out the maximum peak current. If you don't know, you just leave it open, and the calculator will keep that in mind. And it will give you two things. First of all, you can download an Excel spreadsheet with the complete solutions on it. On the other hand, it also gives a PDF with the complete solutions on it. And then that gives you a very good discussion point with your customers, let's say your end customers, to go over the solutions and select the correct one. Because it will be, for example, if you go up to a certain maximum peak current, it will give you a stainless steel solution, aluminum, polymer, a double loop stainless steel. And you can actually select what would be the best for our installation at this point.
Thank you. And I know that all of you are available for the next half of the hour. So Roberto is there in the chat, Henk is there, Güven is there. If there appear some questions, we are there for you to answer this. Otherwise, I'd like to close this meeting, to thank you, Roberto. We have the nice possibility to have you here from Italy. Thanks, Henk, for coming over from the Netherlands, and thanks, Güven, from Frankfurt. Thank you for listening to this, and see you to the next session here.
Thank you.
Thank you.
Thank you.
Bye. Take care.
Bye.